to Basic Theory T107. Okay, so in Basic Theory T107, what we're going to be looking at is data compression. So let's have a look at the question and see if we can answer it on the next few slides. So when a string contains a consecutive sequence of the same character, which is important here for the data compression, the repeating characters are replaced with a combination of the number of occurrences and the character itself in order to shorten the length of the string. Which of the following is the technique? So we've got EBCDIC encoding, we've got run length encoding, we've got Huffman encoding, and we've got cyclic encoding. So let's have a look and see which one of these we are describing. Okay, so let's have a look at run length encoding here. It's perhaps the simplest lossless data compression technique of all. And what that means is that when we do compress the data, we don't lose any of the data, we just convert it into a different format. So RLE is a compression method that converts consecutive identical characters into a code consisting of the character and the number making the length of the run. RLE works by reducing the physical size of a repeating string of characters. So what we can do is, this is the words of how the method works. So let's just have a little look at an example. So uncompressed, a character run of 15 A characters would normally require 15 bytes to store. So here you can see we've got our 15 A's in a row, and each one is going to take 1 byte to store. So let's have a look how we could use RLE to encode this data. In this slide we have 15 A's in a row, and we used run length encoding to encode this. The output is shown here, which would just be 15A, and this just signifies to the computer that there's going to be 15 A's in a row. Thus, after run length encoding, the 15 byte string would require only 8 bytes of data to represent the same string. In this case, run length encoding yielded a compression ratio of almost 2 to 1, and therefore we're able to compress this 15 A's down to almost half as much data as we used before. So therefore B is the correct answer. Let's just explore some of the other examples that we had in the original question just to see some basics behind them. So the first one we had was Extended Binary Coded Decimal Interchange Code, or EBCDIC for short. This is an 8-bit character encoding used mainly on IBM mainframe and IBM mid-range computer operating systems. However, it's also employed on various non-IBM operating systems or platforms, and the list is just given here. Let's just look here at the last two types of encoding. Huffman encoding is a method of encoding that was developed in 1952 by David Huffman. In the same way as RLE, or run length encoding, Huffman encoding is an encoding method that efficiently shortens character strings. But Huffman compression is a variable length coding system and assigns smaller codes for more frequently used characters and larger codes for less frequently used characters in order to reduce the size of files being compressed and transferred. Finally, cyclic code. This is an error auto-correcting code that has algebraic properties and are convenient for efficient error detection and correction. Okay, and we can see, as we mentioned on the previous slide, that our answer is B. So what we've looked at here is some types of encoding where if we have a string, for example, let's say A, we've looked at some different methods to encode that to use less bytes.